In this video, we're going to learn how to handle compound inequalities. And this is when you have two or more inequalities trying to solve at the same time. Now for this first one here, part A, this is actually called a double inequality because you see we have two inequalities in one line. And when you're trying to solve a double inequality, you handle it the same way as if you would a regular inequality where you're going to say subtract 7. But instead of subtracting 7 from both sides, you're subtracting 7 from all three sides here. You've got to keep everything in balance. And we'd get negative 10 is less than or equal to 2x less than or equal to 2. Then we can go ahead and divide all sides by 2. And we get negative 5 is less than or equal to x is less than or equal to 1. And so therefore now we know that the value x has to be in between negative 5 and 1. So my solutions would be bracket negative 5 to 1 end bracket. So double inequalities are a little bit more straightforward than some of the other things. And if we look even at the end here, compare that to the actual answer, it's pretty easy to convert it to interval notation. But this is what we have. The next one here is an AND compound inequality. So what that means is we're looking for numbers of x that will make the first one true and the second one true at the same time. So we solve them individually. So I'll go ahead and add 5 here. We get 3x is less than or equal to 12. Then I go ahead and divide by 3. I get x is less than or equal to 4. And then doing this kind of same idea over here, subtract 3 from both sides. 4x is greater than or equal to negative 2, divide by 4, and negative 2 over 4 is the same as negative 1 over 2. Now if I look at my number line here, this first one says I want to be less than or equal to 4. The second one says I want to be greater than or equal to negative 1/2. And since the problem is an AND, I want to know where both things are true. So that's the overlap here, and that would be the numbers that are in between negative 1/2 to positive 4. So again, when you have an AND compound inequality, you're looking for numbers that satisfy both of them, which on the number line is the overlap part. For part C, we have an OR inequality. Again, you're going to solve each one individually. Subtract 2 here. Divide by 1/3, which is the same as multiplying by negative 3. On the other one, add 4 to that. I get 1. Divide by 0.1. I get 10. So then I'm on my number line here. I want everything that is less than or equal to negative 3 or bigger than or equal to 10. Now if this had been an AND problem, there would be no solution because there's nowhere where they overlap. But it's not an AND problem, it's an OR problem, which means we want all the numbers that work for either one of them. And so if I look at all the possible numbers that work for either one of them, it's everything up to negative 3, and then later everything from 10 on. And so all these together would be the whole solution set for this problem. Now this last one here is technically not a compound inequality. There's only one inequality there, but it's a bit tricky here at this point. So think about what 3x plus 7 to the negative 1 power is. It's really the same as 1 over 3x plus 7 is greater than 0. Now at this point in time, we have not learned how to handle inequalities that have fractions in them like this. It's called rational inequalities. But we can actually avoid that right now because it says that the reciprocal, 1 over 3x plus 7, is positive. And so what you can do is you need to think about that and say, well, if the reciprocal is positive, then the original number had a positive as well. So this is actually the same thing as if it had just been 3x plus 7 is greater than 0. Right? Because again, a number is positive if and only if its reciprocal is positive. Reciprocal doesn't change whether it's positive or negative. So then we could just solve this one. without having to worry about that negative 1 power. And this would be all the numbers from negative 7/3, or sorry, bigger than negative 7/3. So that'd be parentheses negative 7/3 to infinity. And so this is how we solve these types of inequalities.